Hi everyone, it's Miss Dubas here. Welcome to your second lesson on the Global Atmospheric Circulation Model. Please ensure that you have undertaken lesson 1 so that you can ensure that you secure your learning and your understanding within this lesson. You're going to need a pen, you're going to need a piece of paper and a different colour pen that you can use to mark your work. Please make sure you're working somewhere quiet and free of distraction so that you're able to really focus on your learning. And when you're ready, we can get started. So as mentioned, this lesson is going to focus on part 2 of the Global Atmospheric Circulation Model. In lesson 1, we focused on the Hadley cell, and in this lesson, we're going to focus on the Ferrel cell and then follow that up with the polar cell. So we're going to begin with a little recap from lesson 1, just to make sure we've secured that learning before moving any further. So let's recap our understanding of the Hadley cell. So the sun's energy, or insolation, is concentrated at the equator. Warm, less dense air will rise into the atmosphere where it will cool and condense to form cloud. This creates a low pressure belt at the equator, and it's associated with quite high levels of rainfall. As air spreads north and south of the equator, it cools. This cooler, denser air sinks back to the Earth's surface at 30 degrees north and 30 degrees south of the equator. This creates a high pressure belt. We call these the horse latitudes. Now, air travels from high to low pressure. So if air travels from the horse latitudes back to the equator, we call these the trade winds. They're surface winds. If air travels from 30 degrees north and 30 degrees south of the equator, and they move north and south even further, we call these winds westerlies, and they're going to be really important for our lesson today. So in order to check that you fully understand how the Hadley cell works, please complete the activity on the screen now. So you'll need to pause the video in order to complete the task. I'd like you to answer the questions linked to the Hadley cell and linked to lesson 1 about the Global Atmospheric Circulation Model. So your questions are: what is the latitude of the equator? Why does air rise at the equator to create a low pressure belt? Why does air sink at 30 degrees north and 30 degrees south to create high pressure belts? What are trade winds? What are westerlies? And finally, does wind move from high to low or low to high pressure? So please pause the video and then have a go at answering the questions, and then we will mark our work in just a moment. Okay, so we're now ready to mark the answers to those quiz questions. Make sure that you have your other colour pen so that you can make any corrections if needed. And obviously, if you've got something correct, give yourself a really big tick. So question 1, what is the latitude of the equator? It is 0 degrees. Why does air rise at the equator to create a low pressure belt? Air is warm and less dense. Number 3, why does air sink at 30 degrees north and 30 degrees south to create high pressure belts? Air is cool and denser. Number 4, what are trade winds? They are surface winds moving back towards the equator from 30 degrees north and 30 degrees south. Number 5, what are westerlies? Surface winds moving to higher latitudes. And finally, number 6, does wind move from high to low or low to high pressure? High to low pressure. So give yourself a little score out of 6. So we're now going to learn about Ferrel cells. There's a Ferrel cell in the northern hemisphere and a Ferrel cell in the southern hemisphere, and air circulates around these cells. So let's take a closer look at what's happening in the Ferrel cell. So if you look at the diagram, you'll see whereabouts the Ferrel cell is located in the northern hemisphere, and this is mirrored in the southern hemisphere. So let's think about how air circulates around the Ferrel cell. So warm surface winds from 30 degrees north and 30 degrees south of the equator, these are those westerly winds, meet cold air from the poles at 60 degrees north and 60 degrees south of the equator. As warmer air is less dense, it rises above this cooler air into the atmosphere, and this creates a low pressure belt. And if there's a low pressure belt, that means we get higher levels of rainfall. This occurs because as the warmer air rises, it cools, condenses to form cloud, which then results in these higher levels of rain. As the air reaches the top of the troposphere, some of the air moves back towards the equator, but some of it moves towards the poles to join the polar cell that we will review in just a moment. So to ensure that you've understood how the air will circulate around the feral cell, what I would like you to do is to pause the video to complete this next task. I'd like you to put these sentences in order to explain how air circulates around the feral cell. So there are 4 sentences on the screen, but they're in the wrong order at the moment. So you need to work out which order they go in order to complete the explanation correctly. So please pause the video to complete your task and then press play again when you're ready to check your answer. Okay, so we're now ready to mark our work to check that we've got the sentences in the right order. So make sure that you've got your different colour pen so that you can check these as we go. So this is the correct order of the sentences. So number 1, warm surface winds from 30 degrees north and 30 degrees south meet cold air from the poles at 60 degrees north and 60 degrees south. Sentence 2, as the warmer air is less dense, it rises above the cooler air into the atmosphere, creating low pressure belts. Number 3, as the warmer air rises, it cools, condenses and forms cloud, resulting in high rainfall. And the final sentence, as the air reaches the top of the troposphere, some air moves back towards the equator and some air moves towards the poles. So just check that you've got those sentences in the right order. If you need to pause the video again to address any mistakes or make any corrections, that is absolutely fine. So we're now going to find out what happens in the polar cells. So we want to know how air circulates around the polar cell, and you'll see on the diagram the location of the polar cell in the northern hemisphere. This is also mirrored in the southern hemisphere. So air from 60 degrees north and south of the equator will move towards the poles, and as it does this, it cools. That means it becomes denser and sinks back towards the Earth's surface at 90 degrees north and 90 degrees south of the equator, and this creates high pressure. That means very little rainfall occurs in those areas. Air, once it has sunk back towards the Earth's surface, starts to move back towards the equator via surface winds. Now, Antarctica, around the South Pole, is actually the world's largest cold desert, and that is because there is very little moisture in this area, and that is due to the high pressure that occurs at 90 degrees south of the equator. So we're now going to just check on the understanding of the polar cell. So I would like you to pause the video to complete the task on the screen. I would like you to decide if you think these statements are true or false. So number 1, the poles are 30 degrees north and 30 degrees south of the equator. Number 2, the poles experience high pressure. Number 3, Antarctica is a cold desert. And number 4, winds from the poles move towards the equator. So once you've decided if those statements are true or false, you can resume the video to mark your work. So it's now time to mark your answers. If you've got something correct, give yourself a big tick. If you've got something incorrect, you can make your adjustment or your correction. So number 1, the poles are 30 degrees north and 30 degrees south of the equator. This is false. They're actually around 90 degrees north and 90 degrees south of the equator. Number 2, the poles experience high pressure. This is true. That's because cool air is sinking. Number 3, Antarctica is a cold desert. This is true. And number 4, winds from the poles move towards the equator. This is also true. So give yourself a little score out of 4. So as a final main activity, I would like you to have a go at answering the questions that you see on the screen. So question 1, explain why rainfall is high at the equator. Try and link this to air pressure. And number 2, explain why Antarctica is a desert or a cold desert. And again, 3 marks. And think about again how this could link to air pressure. So I'd like to pause the video and have a go at answering those 2 questions. And then when you're ready, resume the video so you can mark your work. Okay, so it's time to mark the work that you've been completing. So on the screen are 2 model answers to the 2 questions that were set. So I would like you to have a go at marking your piece of work. So give yourself a mark for every time you've mentioned something similar to what I have mentioned in the model answer. And if there's anything you've missed out, you can add that in with your different colour pen. So number 1, explain why rainfall is high at the equator. So high rainfall occurs at the equator due to low pressure. So if you've mentioned low pressure, please give yourself a mark. Warm air rises into the atmosphere and cools. You can give yourself your second mark. This cool air condenses and forms cloud. That would be your third mark. However, if you have mentioned Hadley cell here, you can give yourself an extra mark. And question 2, explain why Antarctica is a desert or a cold desert, 3 marks. Antarctica is a cold desert due to high pressure in the polar cell. Give yourself 1 mark. Cold air is sinking towards the Earth's surface, 1 mark, and no clouds can form, 1 mark. So please give yourself a score out of 3 for each of your answers. So that concludes our lesson today on the Global Atmospheric Circulation Model Part 2. Please ensure that you complete the exit quiz just to check on your learning from today's lesson. It's a really good idea also just to think about 3 key things that you've learned from the lesson today on reflection. Well done for all of your hard work, and see you again soon.